The periodic table. We're going to start atomic structure part 2 here. You learned a lot about this last year, but in this little prezi, I'm just going to show you some of the things you should remember and build on some of that information, just so that we have a solid foundation to continue through the rest of the topic. The periodic table is a table that organizes all of the information that we can find about the elements. Remembering the elements are different types of atoms that we find in our universe. When a new one is discovered, it is added to this table. There are various different types of periodic table and the information they give you, but we'll go through the most common here today. You will be used to seeing the elements in some of these states. As most metals will be a metallic substance that's quite shiny, or when you look at copper in copper wire, you see it as that distinctive color. That is obviously billions and billions of that type of element, that type of atom together. The periodic table looks at those atoms as individuals. Now, obviously, they are so small, we can't hope to see them with our naked eye. And only recently, last year, have they worked out how they might go about using lasers to photograph the first atoms. So, the most common periodic table you will deal with in your schooling and going through to chemistry is this one. It has a lot of information on it, but we're going to break it down as the periodic table has been designed to be very logical, and it'll all make sense by the end, hopefully, of this topic. So, each of these squares represents an atom. And here you can see the one we're going to use as an example is boron. Boron has the symbol B. We'll get onto that in a bit later. But I want to focus on the other numbers. Firstly, the atomic number. You might remember from last year that the atomic number tells us how many protons an atom has. The bigger of the two numbers that you will find on the periodic table and specifically the atoms is the relative atomic mass. This often is just a little bit more than double the atomic number. Every atom has a name. It also has a symbol. Often those symbols are very similar to the name. For example, here you can see boron has the symbol B. However, if I jump to iron, you will see this has a very different symbol. This goes back to what iron used to be known as. And in Latin, iron is ferrous. So you can see Fe comes from the Latin name for iron. What do those numbers mean? Well, using this diagram to represent some of the subatomic particles, we can see that a carbon atom has an atomic number of 6. Therefore, it has 6 protons. Those protons are found in the middle, this part here. This middle part is known as the nucleus. It is also where we find our neutrons. Neutrons can be worked out using the relative atomic mass and our atomic number. The way we do this is doing a bit of quick math. To find the number of neutrons, we simply take the atomic mass, which in this case for carbon is 12, and minus the atomic number. 12 minus 6 equals 6. And you can see up here that carbon has 6 neutrons. The other subatomic particle are electrons. Now these are so tiny that they live in shells around the nucleus. Each subatomic particle has a charge. The charge of electrons is negative. The charge of protons is positive, and neutrals don't have any charge and are neutral. The way I remember it is that proton starts with P. P for positive. Neutron sounds like neutral. So neutrons are neutral. That leaves electrons, so they must be negative. The negative and positive charges of the electrons and protons will be explained later when we look at why certain atoms are where they are on the periodic table. Speaking of electrons, this periodic table talks and shows us about the electron shells and the electron configuration. If we go through down to hydrogen, you can see hydrogen has an atomic number of 1. That means it has 1 proton, but it also means it has 1 electron. On the periodic table, the atomic number equals the number of protons, but it also equals the number of electrons. However, this can differ when we get onto ions, which I'll explain a bit later. If we jump over to helium, we can see helium's atomic number is 2. So in helium's nucleus, we would find 2 protons. However, in the outer shell, we see there are 2 electrons, these grey dots here and here. However, if we jump down to neon, the 10th element, with an atomic number of 10, we would expect to find 10 protons in neon's nucleus, but we can also see 10 grey dots, which symbolize our electrons. They're in a specific pattern. You can see in the first shell, we have 1, 2 electrons. And in the outermost shell, we have 1, 2, 3, 4, 5, 6, 7, 8 electrons. 2 plus 8 equals 10. This is a deliberate pattern. It's quite complicated to understand, but if you can just remember at year 10, the electron configuration of the first shell is 2 electrons at most, and then the next shell can have 8, and then the next shell after that can have 8, you'll be doing well. If I just zoom out a bit and you look at fluorine, you can see fluorine's atomic number is 9. In the nucleus, we would find 9 protons. We would also find 9 electrons, and as you can see, the first shell has 2, which is the most it can have, and then the next shell has the remaining electrons. Here you can see 1, 2, 3, 4, 5, 6, 7. Jumping down to argon, you can see that argon has 3 full shells. 2, 8, 8, and that adds up to 18 electrons. If an element has full outer shells, it is known as a noble gas. Argon, neon, and helium are 3 of those noble gases. They are all found in group 18, which is this number up here. Jumping to the other side of the periodic table, we can see some metals. Metals are found on the left-hand side of the table. Sodium was that unusual element in which we can see the name in English is different to its symbol. You can see the pattern continue here of 2 electrons in the first shell, followed by 8 in the second for each of these atoms. But as they get larger and include more electrons, their other shells start to fill up. If we look at calcium, calcium has 2 electrons in its first shell, followed by 8, followed by 8, and then its remaining 2 start to fill up another shell. This rule of 2, 8, 8, 8 is correct for the first 20 elements. However, it is not a hard and fast rule, and as you go through learning chemistry through to year 13, this will be explained in further detail. The periodic table of elements. Last year, we learned that this is where we find all the information about our elements. We know that each element is a different type of atom. Atoms are comprised of protons, neutrons, and electrons. Protons and neutrons are found in the nucleus of the atom, which is the center, and the electrons are found in shells around the outside. There is a specific pattern to the electrons. Only 2 can be found in the first shell, up to 8 in the second, third, and fourth. This rule is correct for the first 20 elements, but can change with others.